All right, let's talk about one of the most critical things you'll face when bringing generative AI into your organization: fine-tuning. Now, this isn't just some tech-heavy process for your engineers. No, this is a high-stakes balancing act. Think of it like this. You've got this incredibly smart, generalist AI, and you need to turn it into an expert for your business. The trick is doing that without accidentally breaking the very thing that made it so smart to begin with. So, here's our game plan. First, we'll unpack the central challenge, what I'm calling the specialist's dilemma. Then we'll look at the biggest risk, what happens when things go wrong. After that, we'll get into the practical stuff, mastering the controls, and then the newer, smarter ways to tune. And we'll wrap it all up by connecting the tech back to what really counts, your business strategy.
All right, so let's get right into it. The specialist's dilemma. This really is the fundamental tension at the heart of all of this. It's the strategic puzzle that every single leader needs to solve if they want to get real, tangible value out of AI.
So here's the billion-dollar question, right? It's the one that's probably on your mind right now. You've got access to these incredible, powerful AI models. But how do you actually make them yours? How do you infuse them with your company's secret sauce, your data, your processes, your unique way of doing things to build something that nobody else has?
And this really puts it in perspective. On one hand, you have the pre-trained model. It's got this gigantic foundation of general knowledge. I mean, it knows about everything from poetry to Python code. But on the other hand, what you need is a specialist, something that's an absolute pro at, say, analyzing your legal documents or handling your specific customer support issues. The whole game is about building that expert on the right without destroying the foundation that it's built on.
So, what happens when that foundation does start to crumble? Well, there's a name for this, and it sounds pretty dramatic because, honestly, it is. It's the big bad wolf of AI fine-tuning.
It's called catastrophic forgetting. And here's the key thing to understand, the part that's kind of terrifying. When you fine-tune a model, it doesn't just add your new knowledge on top. It often replaces its old knowledge. So while you're busy teaching it the ins and outs of your company's jargon, you could be making it forget how to, write a coherent sentence. It's like you're not just training it, you're accidentally performing a digital lobotomy.
And here's what that looks like in the real world. You start out with this amazing, versatile tool. It can draft a marketing plan, it can summarize complex reports, it can do 100 different things. But after you fine-tune it badly, all it can do is one thing, like classify support tickets. And if you ask it what a marketing plan is, it has no idea. You've traded a Swiss Army knife for a screwdriver, a very expensive screwdriver.
Look, this isn't just some technical glitch for the IT department to worry about. This is a massive business risk. We're talking wasted money on computing power, completely unreliable AI tools, and even worse, having to scrap the whole thing and start from scratch. That's a direct hit to your budget, your timelines, and your entire digital transformation roadmap.
Okay, so how do we stop this from happening? How do we get the rewards without all the risk? Well, this is where we step up to the control panel. Think of what's coming next as the essential dials and levers your team absolutely must know how to use to steer this process safely.
These are the four big ones: a low learning rate, training for fewer epochs, applying regularization, and using something called gradient clipping. Don't worry, we'll break down what they mean. The important thing is that these aren't just random suggestions. They're a layered defense system to protect your investment.
Let's make this really concrete. A low learning rate? That's your brake pedal. It forces the AI to learn slowly and carefully, instead of making huge, reckless changes. Fewer epochs? That's like limiting its study time. You don't want it to just memorize your new data, you want it to learn the patterns. Things like weight decay and dropout, they force the model to find simple, robust answers, not just memorize noise. And gradient clipping? That's your stability control system, preventing the whole learning process from just spinning out of control.
Now this right here, this is the cheat sheet. This is what you want your technical leads to have pinned to their wall. You don't need to memorize the exact numbers, but as a leader, you need to know that these controls exist. This allows you to walk into a meeting and ask, what's our learning rate? How many epochs are we running? Are we managing the risk? It's about ensuring your team is being disciplined.
Okay, so mastering those controls is mission critical. But that's the old way of thinking, in a sense, because recently a whole new family of techniques has emerged that completely changes the game. It's all about working smarter, not harder.
And this revolution is called PEFT, or Parameter Efficient Fine-Tuning. The idea is just brilliant. Instead of trying to retrain the entire massive AI model, you just freeze it. You lock in all that incredible general knowledge. Then you attach a tiny new module of parameters, less than 1% of the original size, and you only train that. It's like leaving the giant engine of a supertanker untouched and just adding a small, agile rudder to steer it exactly where you want it to go.
So, with the old-school full fine-tuning method, you're trying to adjust 100% of the model, every single one of its billions of parameters. I mean, the cost in terms of time and computing power is just enormous.
But now, with a PEFT method like LoRA, you're only touching less than 1%. Think about that. This isn't a 10 or 20% improvement. It's a total game changer. It makes this whole process cheaper, faster, and way more accessible. And if you want to take it to the next level, there's QLoRA. It's basically LoRA plus another smart trick that shrinks the model's size. And the business case here is just a knockout. We're talking about taking a massive, state-of-the-art model and fine-tuning it on a single GPU, something you can buy off the shelf. The cost savings are huge, and you're getting performance that's right up there with the old, super expensive methods. It completely democratizes this capability.
So this chart really lays out your strategic options. On one end, you've got full fine-tuning. It might squeeze out the absolute maximum performance, but the cost in time and money is huge. On the other end, you have LoRA and QLoRA, incredibly fast, incredibly cheap, and run on much simpler hardware. For 99% of business use cases, the choice is pretty clear. The efficiency and cost savings are just too good to ignore.
Okay, so we figured out how to do this safely and efficiently. That's great, but that's only half the story. The other half, and frankly, the more important half for everyone in a leadership position, is figuring out if any of it is actually working. How do we measure success?
Seriously, think about it. You've invested time, you've invested resources, you've done the fine-tuning, you've avoided the pitfalls. Now what? How do you prove to your board, to your team, and to yourself that this AI is actually effective? What does good even look like? And here's a huge trap. A lot of technical teams will fall back on these old-school academic metrics, things with names like BLEU and ROUGE. Here's the problem. They're basically just glorified keyword counters. An AI can give you an answer that is completely wrong, totally nonsensical, but if it uses the right words, it gets a high score. If your team is optimizing for these, you are flying blind.
So we need to throw those out and start measuring what actually matters to the business. Ask these questions. Is the answer factually correct? Does it actually answer the question that was asked? Is it relevant? Is it helpful? And of course, the gold standard is and always will be a human expert. Does one of your own people look at the output and say, yes, that's right, that's good? If you take away only one thing from our conversation today, let it be this. You have to define your success metrics before you start fine-tuning. Figure out what working means in real business terms, and then build towards that. This is the single most important step. It aligns the entire project with your actual goals, ensuring your team isn't just chasing a high technical score, but is actually creating business value.
So I'll just leave you with this final thought to chew on. Is your AI strategy built for real, tangible business outcomes, or is it just chasing technical performance metrics? Because at the end of the day, a successful AI project isn't about having the fanciest tech. It's about having the sharpest strategy. This balancing act isn't one in the data center. It's one in the boardroom.